Let's do some easy program now. The sum of numbers. Remember, we did a program like this, sum of numbers, which will be inputted from the keyboard. So the sum of numbers means the user will input the numbers. Then what's the speciality of this? Here the sum of numbers are sum of floating point numbers. That is, the floating point numbers will be inputted from the keyboard by the user, and the program must be outputting the sum of them. So sum of floating point numbers means how many floating point numbers? Maybe n floating point numbers. So who will enter the n? User will enter the n. User will say that I will enter 5 numbers, and then the user will enter 5 floating point numbers. So it's an easy program. You can understand how to do this program. If I just think of this program, then what I will do is I will scan the n numbers. I will firstly ask for n numbers from the user, and once the user says this is the value of n, I will scan it within n. After that, n floating point numbers will be scanned from the user one by one. So firstly, printf enter n. Enter n means enter the number of values that you want to enter. So you can write like that also, enter the number of floating point values you want to enter. So that can be one way of writing it. So once the user does that, once the user enters, you want to scan it. Scanf %f or d. This is d, because the number of values to be entered, that is being entered by the user right now. So that is an integer. N number of floating point values will be entered. So that n is definitely an integer. These number of floating points, say 5 floating point values will be entered by the user. So 5 is an integer. So definitely int n. Now once this is done, once you scan it, after that you have to tell the user printf enter n floating point values. So you can write like this, enter %d floating point numbers /n and so on. Enter %d. What is this %d? You did not enter, I did not enter that. So %d has to be replaced by n. These many floating point numbers will have to be entered by the user. Now comes the scanning part. Now for scanning, what will you do? You need a for loop. The scan has to be done within a for loop, because don't you forget, n floating point values will be entered by the user. So to scan n floating point values, you have to run a for loop and run the scan within that for loop, so that n times the scanning is done, n floating point values are entered. So n floating point values means for I equal to 1, I less than equal to n, I plus plus. This for loop is needed to scan n floating point values, and every time I must scanf a floating point number. So this time it is %f ampersand. You scan it in any variable, maybe number. So don't you forget, this number must be a floating point value. You can call it fnum also. So just to make yourself understand that this is a floating point number. Scanf %d fnum, floating point numbers. So these many floating point numbers, n floating point numbers will be entered by the user every time I will scan it within a variable called fnum. So don't you forget, over here I need an integer I, because n times I must iterate, so that I count that n values are being scanned, and you need a floating point variable called fnum. Now once this scanning is done, you need to add this floating point value. You want to add this, you want to do the summation. So sum is needed. Sum plus equal to what? This fnum. Sum plus equal to this fnum, so that you get this sum ultimately. So this sum must be initialized also. This sum has to be initialized to 0. But this sum is a integer or a floating point number. After all, it is the sum of all floating point numbers. So definitely this sum is also a floating point number. So no doubt this sum has to be declared as float, and sum has to be initialized as maybe 0.0. So you are scanning it every time, and every time the floating point number that is being scanned is being added. In this way, how many floating point numbers are being scanned? N floating point numbers, because for I has started from 1, incremented every time, and is being compared with less than equal to n, which means n floating point numbers will be scanned within fnum every time one floating point number, and that will be added to sum. So finally the sum will be outputted. So before you go to this get ch, printf the sum of floating point numbers is what? %d or %f? Definitely it is %f this time, because the sum is a floating point number. So %f. So now you can say, if you run the program, this should run smoothly. Let me run it. Alt enter the number of maybe 5. So enter 5 floating point numbers. Remember, this 5 that I entered was scanned within n. Then I said enter %d floating point numbers, where %d was replaced by n, so enter 5 floating point numbers. Now I enter these 5 floating point numbers, maybe 32.1, 13.8, 91.2, 9.4, and the last number may be an integer also, 7. 7 will be treated as 7.0 over here automatically, because the floating point number ultimately you are scanning it within a floating point number as %f. So automatically here 7 will be converted to 7.0, because you are scanning it within %f itself. So the sum is 153 point. Now this is something very interesting. You check out what is the sum. 32 plus 13 is 45. 45 plus 91, that is 136. 136 plus 9 is 145. 145 plus 7 is 152. So this part is before the point, the part is 152. Now after the point, 1 and 8, 9, 9 and 2, 11, 11 and 4, 15, which means it is 1.5. 0.1, 0.8, 0.2 and 0.4 makes it 1.5. So 152 was this part, and after the decimal part is 1.5. So it is basically 153.5. But see the output is 153 instead of 153.5. It is 153.499985. Now this is interesting. Why is this happening? This is happening because this 153.5 and 153.4999 something, that is almost same, but when internally computer is adding the floating point numbers, it is treating the numbers in a different way, in a way which we call binary. We will understand later. So in that process of being converted internally to binary and being converted back to decimal, this slight amount of change of floating point numbers do occur. So this sum, instead of showing 153.5, is showing 153.49999 something, which is actually 153.5 itself. So this is how it is done. How to change it and actually make it 153.5, there is a way which we will come to very soon. But for the time being, suppose this was not sum, but instead of that you were asked that you calculate the average. Then what? Average of floating point numbers, then what? Say this is not sum of n floating point numbers. Instead the user asks you that you enter, or the program has asked you to find the average of n floating point numbers. So how to calculate average of n floating point numbers? Very simple. Here instead of sum, this will be written as average. The average of floating point numbers is %f. What is this average? Is not it sum divided by n? Check out, is not it so? The sum contains the sum. You want to divide the numbers, divide it by the number of values to get the average. What is the number of values? The number of values is n. So you divide sum by n, you get the average. So you can run this program once more and check out. Say this time I enter phone numbers: 12.1, 11.7, 1.2 and 2.3. So check out what? The average is 6.825. 12 plus 11 is 23, plus 1 is 24, plus 2 is 26. And the right hand side part 26, and say 1 and 7, 8, 8 and 2, 10, 10 and 3, 13. So 26 and 1.3 makes it 27.3. If you divide it by 4, check out, it will exactly be 6.825. So you can take a piece of paper and check it out. We will find that the answer is exactly the correct one. So over here you get this average. One small change I may ask you also, say average of n floating point numbers, this n is not entered by the user. You remember one time I told you that how many numbers the user will enter, user does not know from the beginning. That is, at the beginning user does not know whether it is n or 5 or 7 or 8. User will keep on entering the floating point numbers one by one. At one point of time when the user feels that, no, I don't want to enter anymore, user will enter a certain value which will indicate it is ended. And that value might be minus 32768. Do you remember? This was the number I talked about, minus 32,768. So that can be entered by the user to indicate that he has completed entering the floating point numbers. So over here, I cannot ask from the user that you enter how many floating point numbers you want to enter. So I just comment out this part of the code where it says that n is being scanned. Instead, there is no n over here because user does not know how many numbers are to be entered. So this n is gone. This n is not needed anymore. So let me first calculate the sum itself. Instead of the average like we did, let us calculate the sum. So for calculating the sum, what to do? I say I need this I need to calculate this for loop has to be continued everything I need, but n is not needed. Now the sum of this floating point numbers without knowing n, how to do? This %d floating point numbers cannot enter. So I can write, because I don't know n, enter the floating point numbers one by one. And I tell the user minus 32768 to end. Let me make it minus 32768.0 to end, because we are entering floating point numbers. So this part is absolutely correct. I cannot say n, this n is not needed, and you know that this n cannot be entered by the user. User does not know how many values. So I tell the user, just start the program like this, enter the floating point numbers one by one, minus 32768.0 to end. So over here what to do? I can run the for loop for I equal to 1, the sum equal to 0.0. What condition will I check over here? I less than equal to n. See, I don't know what is this thing. Instead, one thing I know, that if this fnum is scanned as minus 32768, then I will have to stop the process. So do you remember break, if checking and break? Same thing, if fnum is scanned as minus 32768.0, then you know you need to break out of the for loop. The for loop has to be broken out of. Otherwise, I will keep on scanning and keep on adding. So do you notice one thing? This I equal to 1, I less than equal to n I plus plus, this counter is not needed at all. Instead, if you remember when I did it with while, it was just while 1, no condition at all. So basically this counter I is not needed at all. Not needed at all because no counting of numbers is happening over here. I am just scanning the numbers one by one without counting. I am just scanning it one by one. I know if I get minus 32768, I will break out. So this for loop does not need the I to be counted. This I equal to 1 is not needed. I less than equal to n is not needed. I plus plus is not needed. In fact, this I itself is not needed. This int I is itself not needed, because I don't need to count how many times the loop will iterate. I just need the loop to iterate, that's it. I don't know how many times it will iterate. That I equal to 1, I less than equal to n, I plus plus, why was it given? It was given to check that the loop iterates n times. Here the loop's iteration I don't need to count, it just needs to iterate. I know if I scan this fnum as minus 32768, I will have to break out. So no counter is not needed. Now this is interesting. That means this part between these two semicolons remain the condition which is not needed, and after this semicolon is the iteration, that I plus plus, which is also not needed. So can I write it like this? The answer is yes, you can write it like this. This for only initiates the sum to 0.0, and this part is not there, but you need to put the semicolon because for knows that within it two semicolons must be there. But the condition between the semicolons is not there, the iteration after the final semicolon is not there. Only you write these two semicolons indicating that two semicolons are there. But between this nothing is needed at all. This program will work absolutely fine. Only the initialization sum equal to 0.0 is needed. Here the average is not being done, the sum is being done. So once again I change it back to sum. The sum of floating point numbers is percentage, sum by n is also not needed. Now I run this program and see what happens. Alt R, enter. Enter the floating point numbers one by one, minus 32768 to end. So I just made 32.1, 21.5, 13.9. Let us end over here. Only three numbers, minus 32768.0 to end. So I do exactly that. See, the sum of floating point numbers is 67.5. So 32 plus 21 is 53. 53 plus 13 is 66. 66 is the left hand side. Right hand side, 1 plus 5 is 6, 6 plus 9 is 15. So 66 and 1.5 makes it 67.5. You can take a piece of paper and check it very easily. The answer is absolutely correct. So this one is absolutely fine. Only one thing, had this been, only another thing I just point out before going to the next part. See, one thing, suppose I did not do the sum equal to 0.0 over here. Instead, I initialize sum equal to 0.0 right at the time of declaration. So over here the sum equal to 0.0 is not needed. So this part I also can get rid of. So this for loop can also run like this. No initialization, no iteration, no initialization, no condition, no iteration. Only the for loop is needed to iterate without any check. And let me tell you, this is just like while one. Writing while one and writing for semicolon semicolon is the same thing. Semicolon semicolon means no condition checking is there. So no condition checking is there means it is an infinite for loop, like while one is an infinite while loop. How to break out of that while loop? By an if break. So this semicolon semicolon is an infinite for loop. How to break out of it? Again by an if and break thing. But had this been to calculate the average, then what to do? See, to calculate the average, I need to know how many numbers are there. Please check this out. To know how many times I need to know how many numbers are there, I need to count. So how to do that? Very simple. I can do one thing now. I need to count. See, had there been n, user would have told from the beginning how many numbers, then I would have done sum by n, which I did last time. You remember, to calculate the average I did sum by n, but over here I don't know n because user will not enter this n, this part is commented. So I need to count how many numbers have been entered because before the user enters minus 32768. So how to count that? For this you can reuse this I again. For I equal to 1 you start and you keep on as I plus plus. The I less than equal to n condition checking is not there because there is no question of condition checking. But you have started I from 1 and keep on incrementing I plus plus. You know one thing, that every time you go to the loop I has been incremented by 1. So first time when you entered I was 1. Second time you entered I was 2. Third time you entered I was 3. Fourth time you entered I was 4. But this average, when you go out of this loop, when the number is minus 32768.0, you break out, you know I contains a certain value. So if I contains 4, how many numbers have you entered? 3, because last time minus 32768 was entered when you have broken out. When I is 4, you enter I as I with 4 the last time and you break out. Last time I4 was, fourth number was not scanned. The fourth number which was scanned was minus 32768. So you automatically break out, which means that over here you need, I is basically the containing one number more than the number of values entered. So here what is needed is the average of the number is sum divided by I minus 1. 1 less than I is the number of values entered. So this is not sum, this is average. I think you understand, but still I will make you understand with an example. Suppose the user enters 3 numbers. First time enter with I equal to 1. First number scanned. And that is not this minus 32768. You add it with sum, you go to the start. Second time it enters with I equal to 2. Second number scanned. It is not minus 32768. Add it to sum, go to the start of loop. I is 3, entering with 3. Third number scanned. 3 numbers will be there. So third number scanned. Minus 32768 is not the number. So you break out of, you don't break out. You come over here. So the f num is added to sum. Third number added. Go to the start of the loop. I becomes how much? I becomes 4. You scan the fourth number. The fourth number is minus 32768 because 3 numbers were to be entered. So fourth time definitely user enters minus 32768. You break out of the loop and come over here. What was the value of I? I is 4. How many numbers have been entered? 3. So to calculate the average, you need to divide the sum by how much? You need to divide the sum by 3. So it is sum divided by I minus 1. The job is done and your program will show exactly the average. Let me run it once and see how it works. Oh, one error, yeah. One error is there because I has not been declared. You have used the I this time, so an int I is needed. Now run it, it will run absolutely fine. Enter the following floating point numbers one by one, minus 32768 to end. So again let me enter 3 numbers, 56. 56 automatically is taken as 56.0, 32.1 and 21.1. So this time 56 and 32 is 88.1, 88.1 plus 21, that is 109.2 is the sum. So you need to enter now minus 32768 to end. Minus 32768.0 to end. Average is 36.3999999. Check out how 56 and 32 is 88, 88 and 21 is 100, 88 and 21 is 109, 109.2. 109.2 divided by 3, it is exactly this number, 36.3999. You can take a piece of paper and check out that it works absolutely fine. I feel you understand, you have understood how it has been done. So I have shown you how to calculate floating point numbers sum and floating point numbers average. So let us take a bit of break and come back again with the next program. Thank you so much.